Let summation running from 1 to infinity an and bn be two series where an equal to minus 1 raised to the power n into n divided by 2 raised to the power n and bn equal to minus 1 raised to the power n divided by log n plus 1, and it is defined for all natural number, then both series an and bn are absolutely convergent. Series an is absolutely convergent but conditionally convergent. Bn summation an is conditionally convergent but bn is absolutely convergent. And option D is series an and bn are conditionally convergent. So here two series is given to us and their nth term also, and asked about absolute convergence and conditionally convergence of these two series. First, I am going to check for absolute convergence. For absolute convergence, we have to make nth term positive. So mod of an equal to n upon 2 raised to the power n, and bn mod of bn is 1 upon log n plus 1. For absolute convergence, we have to make this term as positive. Now this is positive term series. So you can apply any test which imply the convergence for positive term series. So ratio test will be helpful here because of you can look the mod of an and mod of bn. So directly you can understood how ratio test will be helpful here. Therefore, mod of an divided by an plus 1, it is mod of this one and this one also. And finally, mod of an equal to an plus 1, 2n n plus 1, because of other term will be cancelled out, and limit of mod an divided by an plus 1 equal to limit 2 upon 2n and 1 plus 1 upon n cancel out by n, and it's equal to 2. This is greater than 1, so absolute convergent. It means series an is absolute convergent by ratio test. Now come to the point. Series bn summation mod bn equal to 1 upon log n plus 1, and you can write in expansion form 1 upon log 2 plus 1 upon log 3 plus 1 upon log 4 plus and so on. Now log n always less than n for all n greater than equal to 1. So log reciprocal of it will be greater than 1 upon n. It means this will be greater than 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus and so on, and this is series summation 1 upon n type, and we know the result. This series is divergent. So by comparison test, this series is not absolute convergent. This is not absolute convergent. Now remember this point. If two series summation un and vn such that un is always less than equal to vn, then convergence of vn implies the convergence of un or series un, and divergence of smaller un, it means un implies the divergence of vn. Remember this test or result, it will be helpful in various cases. So absolute series of bn is divergent. Now test for conditionally convergent. Because of this is alternating series, so apply Leibniz test. This says after making positive term series, limit of nth term should be 0, and decreasing sequence means, that is, if un is positive term series, or after making positive term series or sequence, or after making positive, then un is always greater than un plus 1 for all n, and limit of un should be equal to 0. This is necessary condition for series, so it is direct understood. Here 1 upon log n plus 1 is greater than 1 upon log n plus 2, because log n is less than log n plus 1, so its reciprocal 1 upon log n greater than 1 upon log n plus 1. So 1 upon log n greater than 1 upon log n plus 1, it means decreasing. Now check limit is 0 or not. Limit of log 1 upon log n plus 1 equal to limit n tends to infinity 1 upon log n plus 1. When n tends to infinity, this denominator will go to infinity and 1 upon infinity equal to 0 or tends to 0. So it is conditionally convergent, and An is absolute convergent. Summation An absolute convergent and summation Bn is conditionally convergent. Now match which one option is true. An is absolute convergent but Bn is conditionally convergent. Option B is true here. Option B is true